Hi there. So when you're making your Boombot version 2, just as on all the previous versions of the Boombot, we're going to do a little bit of surface mount soldering. And surface mount soldering might be new for you, but I've done this with students for many years, and once they give it a try, uh, actually I think they come away realizing that there's some things you can do with surface mount soldering that are actually a lot faster and easier than using traditional through-hole techniques. So this is going to be the first step that we do on our board because we're going to use hot air to do our soldering. And you can use just a standard heat gun. I've got a custom device right here. I picked it up at the local electronics shop and it looks something like this. It's nice, it's temperature controlled, and best of all, it's got a little sensor so that when I put the heat gun back down, it stops heating up the tip. And so you don't leave it sitting around and burning people. I've also got some solder paste right here. And the solder paste that I've got, this is from MG Chemicals, but you can find solder paste like this. You want it to come in a syringe. And you can see I've got the leaded solder right here. I still find leaded solder works a little bit nicer. And I've got the no clean variant. So 63% tin, 37% lead solder right here. And what's really neat about the solder paste is that where your regular rosin core solder has the flux running down the inside of a very thin tube of hollow solder, your solder paste has little round pellets. If you zoom in really closely, you can see little round pellets of solder embedded in flux all around it. So usually when I'm not using this for a while, I'll take it and I'll store it in a fridge or someplace, not the freezer, but just someplace nice and cool so that the flux doesn't feel any tendency to evaporate or age out, and it'll last a little bit longer. Make sure you keep the tip around here and you can twist that little tip off. This is a lure lock tip to use the terminology. And I always make sure that I've got a couple pieces of paper sitting around because you don't want to have your solder paste ending up sitting on your desk or anything like that. The the I mean, it's leaded solder, and it's just nice to not make a big mess out of everything. Now, the other thing I'll use the paper for is for doing a couple of practice runs before I get started. Now, I'm going to apply solder paste to these pads right here for the surface mount chip, and my surface mount chip is going to go on right here, and then we're going to solder that into place, but I'll talk more about that when we get to that point. And so what I want to do is I want to practice laying down some solder lines. And so here's my syringe right here, and I'll tend to hold it kind of in my hand about like so. And instead of pushing with my thumb, I'll kind of push right here with the base of my hand. It's a little bit thick, and it does take it a while to go. You can see it starting to come down the tip right here. Now you'll notice that the tip I'm using right here is green, and it must have dried up a little bit, and I think I've got a bit of a clog in there. Now, that might happen your first time out if you're using solder paste that's been sitting around for a little while. Let me just squeeze a little glob out right there. It should flow like that. Now that's obviously too thick for anything we want to do with, that is quite thick. I've had this out of the fridge for a little while to let it warm up. That's flowing a little bit more nicely right in there. And you can see why I'm glad I've got some paper sitting around right here just to wipe those tips off, keep everything nice and clean and tidy. There's no sense creating a big mess. Now, the tips come in different sizes, and the size I've got right here, I can't remember if it's a 20 or a 21 gauge. If they start to clog up, keep a resistor handy, and a resistor should be just about the right. This resistor is just a little bit small to focus down there. Okay, just a little bit tiny to fit down there. And sometimes you can poke a resistor or some narrow little thing right back down in there to clean out the tip. Just gonna see if this flows a little bit nicer. Just going to set that off to the side now. I'm going to get a different tip to try right on here. Okay, so anyway, what happened there was that the first little bolus of solder paste to come out of here, it kind of dried up in the tip a little bit because it's been sitting in my cupboard for a year, well, in my fridge for a year, and not next to the food. We don't put lead next to the food, and so it kind of clogged things up. The other thing I've done is I've switched tips right here, and the green tip, as you can see, was a 21 gauge tip. Well, not that you can see it's 21. The green indicated the 21. I've switched to a pink tip, which is a 20 gauge tip. And I think that should work fairly well for what we need to do. Here comes the solder. And you have to hold on to it for a little bit and just gentle pressure. You're not trying to blow everything apart right here while it comes through. And there we go. Let me just zoom in on that so you can see that little, the focus button will probably help right there. And there you can see I've got just a little bit of solder paste coming out right there. When I'm done, I can just mark it off like that. So there we go, a 20 gauge tip. The pink one works really nice and gets us about the right diameter of solder. And like I say, keep your paper handy so that you can do things like that and work on it there. Now, we're only doing one surface mount component on here, and that's going to be the L293 driver chip right in the middle. And you'll notice, of course, that we've got a notch marked on here, and that's so that when we set our L293D right on here, we can match those two notches up, and they'll line up with each other. And let's just make sure we can see that notch. Okay, you can sort of see it right on there. There's a notch on there. You'll see it for real life. Sometimes the camera doesn't capture all the lighting quite so well. And I'm going to stay zoomed in on there. That was a fairly nice shot right on there. Take your chip out of the way. And this is a fairly simple process. And when you're considering you're soldering lots of leads, it works really cool. Before I get in there too much, you'll notice that we've got a couple of thermal vias right here. Now, after I got this board, I realized I should have left the solder resist, the blue material right here, away so that we'd have better thermal conductivity to the copper on each layers. The middle 4 pins of our chip on each side are ground, and that's primarily so that they can conduct heat into the board, and the vias help carry it through to the other side of the board. Okay, well, that's not exactly related to soldering. However, the solder paste is related to soldering because the solder paste will repel solder when we try to heat it up. So now we just come in here and we heat up, we're not heating it up yet. We extrude a little bit of solder and you just keep coming along right here and gently keep squeezing that solder paste out. Now you'll notice that the solder paste has jumped from pad to pad right in there. Okay, and I didn't put down a particularly straight line, but you'll notice it's jumped from pad to pad. Try and focus in on that. And that's okay because the solder paste will repel it. Not only that, even if you, the solder mask will repel the solder when we heat it up. And even if you don't have a solder mask on there, the solder only wants to stick to hot, clean metal things. And you can see here that we've got some nice clean metal things for it to stick to. And so there we go. All right. We now have solder paste on each side. Let's just try and set that up so we can get a really good picture of that without a lot of glare on it. I think we're zoomed in as close as we can get. We'll focus in on there again to make sure it's looking really nice and clear. Now I've got a pair of tweezers and I'm going to pick up my L293D quadruple half H motor driver chip right here. And using the tweezers, I'm very carefully going to place it on there, checking to make sure that I get the notch at the right end. And then just press that down into place. And as I do that, I want to make sure that my pads are all lined up with the pins on the chip. Now, they don't have to be 100% perfect. So long as you're really close, the surface tension of the solder is going to pull that in as we heat it up. Okay, I'm now going to take my heat gun right off here. And again, you could use any standard heat gun. I find having a little tinier tip on it kind of helps focus the heat a little bit. And what we're going to do is we're just going to heat this up. In an industrial application, they would have used they would have covered the entire circuit board with a very thin piece of foil metal that has had the all of the places where you want solder to go laser cut or etched out of it. And then you would have just done a silk screen printing technique, kind of where you squeegeed the solder paste right across to fill in the gaps. And then you would have come along and a robot would have placed all of your chips and all of your components in place for you. Really, really fast pick and place machine. Amazing accuracy, amazing precision, and part of the reason why circuit boards can be so compact and so inexpensive these days. Then the whole thing goes through in an oven. But you could do this in a toaster oven if you want. But what we're going to do is we're just going to take this, got this set to 450 Celsius, and you can see as I go along this side that the solder liquefies a little bit. Okay, it heats up, and you want to keep going, and you want to watch until it gets nice and shiny. So just keep going in there, and you can see it spread out a little bit, and then just gently spread that heat back and forth, and then let it go. And right in there, you see this little transition where it starts to get nice and shiny. And as it gets nice and shiny, it stops jumping between the pins. And there we go. I got a little bit left down right here. Just going to heat that up. That little gray section right at the end needs to get nice and shiny and get all sucked in right there. Now I'm going to let that side of the chip cool. Oh, I've got just one little jump remaining right down in here in between the pins. I might have had just a bit too much solder right there. We'll take a look at how to fix that in just a moment. Let's come over here and do this side. It takes a little while. There we go. We can see the solder start to heat up, and once it reaches its melting point, it becomes nice and shiny. And just at the ends, if there's any extra that's kind of crept to the outside right there that's still looking dull and gray, that's still paste. Just going to make sure I heat that up. Yep. Looks like I got it all. Well, that's about it. Not bad for soldering up that many pins that quickly, eh? Okay, so that's in there right there. You can see that, darn it, I didn't quite get it perfect. There's a little jump right in here, and there may be other jumps that we haven't seen just yet. Let's take a look right here. You can kind of hold it up and look at it on an angle. And there you can see the one jump that's causing us a problem right on the right-hand side of the screen. The other pins are looking pretty good, and you kind of try to tilt it up and look down underneath them to make sure that they are flush to the board and that you see nothing but shininess right in there. And we can flip this side over and we can take a look right in here, And again, just trying to hold it on an angle so I can get a nice clean look right in there. And that looks like it came out pretty good too. I see right in here there's a little bit of gray left at each end, which kind of looks to me like right in there, a little bit of unmelted solder paste. And I'm just going to see if I can wipe that up with a little piece of paper right here. Get it out of the way. Yeah. Okay, that's looking pretty good. Now, I'm just going to take a moment here and heat up my soldering iron at my bench right here, because you can finish this up with a fine tipped soldering iron. In fact, oh, I don't have a particularly fine tip here, but in fact, any soldering iron is probably good enough for cleaning up a little glitch like that. The finer the tip, the better. Now, the next thing you want to do is you want to get a multimeter out, and where did I put my multimeter? I usually keep a multimeter sitting around in one of these benches drawers here. My desk is getting a little messy. Let me go grab a multimeter so we can do some tests here. Okay, we're back. This is recording again, yes. So we've got the chip on the board, and I went and grabbed a multimeter here, and I've set it to conductivity mode. Now, of course, you can use resistance mode in our standard bench meters in the shop, but you have to look up at them. This one makes a nice beeping sound when you have a connected circuit. So what I like to do, and let me zoom in here for doing my testing so you can see it a bit more closely and you'll hear the beeping. Okay, is I want to make sure that only pins that are supposed to be connected to each other are connected to each other. So if I contact right there, there's no beep because those are two separate inputs. And if I connect right here, there's no beep, and you can check down here, that's good as well. If I connect right there, however, right here, we get a beep, and that's fine because the middle 4 pins all go to ground. Those are intentionally hooked together. 1, 2, 3, 4. Now this one shouldn't be connected to there. That one shouldn't be connected to there. That one shouldn't be connected to there. So that's all looking good over on that side, and I'm just going to spin it around so I can do my test on this side. And really, this is an important test to do because you might not see a flaw, and if you go through and solder up the rest of your board. Now, right here, we already knew about a flaw right there. We're going to come back and clean that up a little bit. That was where we saw the solder jump right in there, but there's no flaw between there and there. Again, middle 4 connected to ground, so those are good signs that we're hearing those beeps. No beep right there, no beep right there, no beep right there. So we've just got the one jumped joint right in here that we have to clean. And that, even though I don't have a super fine soldering tip at my bench right now, works great if you have a super fine tip, but this is just sort of a generic standard tip. You can just come in here and heat that up. There you go. And wipe that away. If you wanted to, you could solder this up just with a fine tip soldering iron. And I go back and I test that and I make sure that that's not connected. That's not connected. So that's really good. I've got no short circuits that aren't supposed to be there in between the pins. I've got the little notch right here at the same side as the notch. Now we can see that in the video a little bit better. The next thing I want to do is I want to make sure that I have good connections between each of these pads and where they come out to. So for instance, this one right here, I can see that there's a little trace of wire that comes out right here. And I do have a good connection right to there. So I have an electrical connection between the circuit board and where it's supposed to go. This one comes out to right here, and that's a good connection. And this one over here, you can see comes out to right here where it goes to the motor. And you can see that pad right there is connected, but I'm not getting a connection between the chip. So weirdly, I had too much solder down here, not quite enough right there. And I bet if I push down on that pin, no, I don't have a connection right there. And that's an important thing to detect right now, because if you went out and you were to use this board without having checked that, you'd have a problem and you wouldn't know if it was your software or your hardware or what's going on. And now, because we've tested it right now, we know definitively that it's the hardware. And again, it's a little easier to clean up with a with a very fine soldering iron tip, but just put that on there, heat that up, and you can add a little bit of solder right in there. You just want to make sure it gets in there and it flows into that pad. Now, you can solder your entire chip together like that. So if you don't have the solder paste and don't feel bad about that, you're going to be just fine. But let's take a look right here now. There we go. Now we've got a connection right in there. And just double check, and we didn't short out right in here. Now these middle four all go down into ground, so they should connect to anywhere on here on the board that says ground. So I can test somewhere else off on the board, and we know they're all connected together. You can come in here and you can see this one. You can follow its copper underneath the solder mask. It's connected right there. This one comes off right here and connects to right there. And this one comes into this big pad right in here. And this big pad of solder, where does it come out? This looks like the plus 5-volt line for the entire board. Oh, maybe, no, sorry, this isn't the plus 5. This is the motor power. This comes all the way back over to, there we go, where I turn my motors on. So that's hooked up right on there. Let's come through and do this side of the board right now. And let's just see this one right here. That was a motor power. Where does this one come out? This one comes in here. Oh, this one comes into the plus 5 for the board, so I can connect that to any of the plus 5s. Where is that one connecting? Oh, is that a tricky one on the corner that runs back underneath the board and comes out at the other end somewhere? I don't see it doing that. Look in there carefully and say, where does that one go to? Why is that one not connected right in there? So just, sorry, I was looking at that myself. You can see right in there. This one right here, I need to find out where that connects to so that I can confirm. There we go. That's where it's supposed to be connected. It does go underneath the board all the way through. So you need to know a little bit about the board, and that's why I give you the schematic diagrams. Those are the 2 enable pins for the chips, and they're connected to each other, and we know that this one's connected into the board, so that's fine. This one right here comes through and connects to right there. That one connects to right there. These are all grounds, and we know they're connected to ground over on that side of the board. Down here, this one right here comes out and connects to that side of the motor. This one right here comes out and connects to that input. And this one right here must connect to our plus 5. So find anything that says plus 5 on your board, and we've got a good connection. Okay, so 2 really important things to check after you've done your surface mount soldering. Check to make sure that none of the pins are connected to each other, and check to connect that they are connected to those things that they're supposed to be connected to. There you go. Surface mount soldering. Now, this is what we call an SOIC, small outline integrated circuit format, and the pins are spaced about 50 thou apart. Okay, so the pitch would be 50 thou, or that's 1 and 1 1/4 millimeters apart, and that's actually about the biggest surface mount chips that you're going to get. I've successfully soldered surface mount chips using this technique down to about 25 thou pitch, which is getting pretty fine, about half this spacing right on here. But for your first surface mount soldering project, why not do it with an SOIC chip? And if you're absolutely stuck, as you saw, you can actually use standard hand soldering techniques with a very fine tip to solder this onto your board. Alrighty, now it's time to hook up all of the standard through-hole components.